tonight. My name is Magdi. I am R&D manager at rhames. A brief overview about the company. We pride ourselves on the diversity of services, equipment and expertise. Our flexibility, I think, is our strength. We provide our customer with solution to their challenges. We do designing, manufacturing. We take your project from A to Z. We have a partnership with international company called Flockweg. We are expert in separation technology. Actually, we do manufacture a machine called drum thickener in-house. It's basically a separator, separate water from sludge. We do all sorts of projects. We do remote condition monitoring, IoT projects. We monitor vibration, oil contamination analysis, control system and optimization. If you need more information about the company and what we do, just come along after the presentation and I will be happy to provide you with more information. So today's talk will be the design and deployment of dissolved oxygen remote monitoring and control for the environment agency using IoT. Thanks to IoT, make things happen. I don't like they say IoT make things easy. It's not. It's affordability. I think it's the right word. So in this presentation, I'm gonna give you a bit of introduction, design and implementation. Try to not go deep into technical stuff. Result in discussion, and we will conclude that with the conclusion and further work. So we know dissolved oxygen play a crucial role in water quality and in environmental preservation and in defining quality of life for fish. So the story behind this project when we started it, and I chose this project because the customer just show how they satisfied about the result. What happened is, I will start with this presentation. I will give you the problem overview, the challenges that we face, and how we solve it. So we sat down with the customer like 2 years ago, and they told us they had a disaster. One day in the morning, they woke up, they found thousands of fish floating on one of them lakes. The result of that, the cause of that, is the lack of dissolved oxygen. The oxygen in these lakes dropped down, caused that problem. So we know there is no real-time monitoring. We asked them, they said they got handheld sensors. They go every morning in the lake, put the sensor, get the reading, go back, write it down, and do a monthly review. So, no real-time monitoring, no automatic control. And I will talk about the control later in different slides. So, again, smart system needed. We start thinking about using IoT to overcome this problem. Before going to the aim, I would like to share you with this article from BBC News. Last July, they published this. River Avon Anglian got I will quote actually this exact article. The environmental agency said there had been significant number of fish deaths and fish in the distress incident. It believes to be linked to lack of dissolved oxygen as a result of high temperature, low pressure caused by thunderstorm. Why I'm sharing you? Because in last July, I got a text message on my mobile saying one of the lakes has got the oxygen level drops down. And I still remember that. And it made me happy because the system is worked. And I shared this, we published the paper actually, it will be around Christmas, hopefully before Christmas time, up in IEEE, and we published it in Sapienza University in Rome. So we know that our system working, and we know how this important problem that we solve. So let's go quick about the aim. Again, monitor water quality, environmental preservation, design a smart system using IoT, collect these data, dissolved oxygen and temperature and analysis. Early warning system, this is really important because they ask us, they want to know at night, early morning, at weekend, what happens. So our system can provide you with email and text message sending you alert. Also investigate the controller part, which I will talk in details in the coming slides. Here's this picture is showing me setting up the first prototype 2 years ago. Let's move now to the design and implementation, how the system works. So the challenge was this is harsh environment. There is no Wi-Fi signal. Some area there is no power supply, so we need to use solar panel. And we have to choose the right sensor. We got two choices, optical sensor or electrolyte one. They prefer, the Environment Agency prefer electrolyte one because of the harsh environment. There's a pros and cons. I can talk to you about it later after the presentation. And this slide show the control bit. In those lakes, they use aeration pump and they use them manually. So every day they go to the more than 14 lakes actually and press a button to kick off the aeration pump to produce oxygen on those lakes. So we did that wirelessly. This is just a basic flow chart, the communication between the sensor and the cloud. By the way, one of the challenges I've mentioned is the Wi-Fi. So we have to use a GSM model. So we found a microcontroller with the integrated SIM card that's able to send the data to cloud and then get it back to our dashboard. Here, the control bit, if the sensor value less than the threshold, activate aeration pump and send us a text message or email or both as alert. System high-level architecture, this is just for the safety. We're using API to transmit the data. I'm not gonna dive in deep in these details, but this is the result. This is our dashboard and the customer dashboard. We're using like traffic light system, green, red, yellow. Again, this is the temperature and dissolved oxygen, and we added a location. This is here, you can see 4 lakes located, yeah, if the dissolved oxygen below 3 milligram per liter, for example, the aeration pump will start, and at the same time we will get a notification in our mobile phone. The system working every 5 minutes. Due to the cost of the SIM card, every 5 minutes we get a signal. This link, I can press it in and it will drive us to the main dashboard that will show you exactly now what is the reading of the dissolved oxygen and temperature. Result and discussion. When we started, there is 2 different types of sensor we use. This is just sampling data, comparing 2 different sensors. Just I want to share it with you, but this is the main thing here, which is the control. The green lines here show you the dissolved oxygen. The orange one is our set point, which is 3 milligram per liter, and the blue one is the aeration pump. If you see here, there is 6 incidents here when the dissolved oxygen goes below the set point, and we can see the aeration pump just kick off and start producing oxygen to those lakes. So once this level is reached, the aeration pump stops, and that's the DO level returns to decrease. And I use a technology, it's old technology, RF, radio frequency. I use something called RF 433 because if it's harsh environment, I wasn't happy to run cables around these between the device and those phones. In conclusion, so the finding was like we able to detect dissolved oxygen and temperature and send the data to the cloud, then to the customer, and we can get a notification as well. The implementation of the automatic control able to force the DO level to increase. Further work here, this is the thingy is we thinking to add pH and turbidity because we know they are really useful for water quality. Our system, we call it plug and sense because we can at the moment just buy a pH sensor or turbidity and plug it in. We don't need to redesign the whole thing. Just adding a few codes to the program and it will be done. That's all from me. I hope you enjoy it. Thank you very much. And if you have any questions, just let me know. Thanks a lot.